Today we're going to be looking at finding the area of composite figures. Before we start our lesson, let's look at some vocabulary. A composite figure is one figure that can be divided into another figure. Area of a triangle, half base times height. Area of a trapezoid, half height, base 1 plus base 2. And area of a rectangle, base times height. So since we're dealing with composite figures here, and if you remember with composite figures, it's one figure that can be divided into another figure. So you want to divide this up. So this shape here kind of looks like a triangle, so I'm going to make some dotted lines here to form a triangle. Let's start with the easy stuff first. So I have here a rectangle now. And I've got two sides longer than the other two, so I'm going to multiply the area of a rectangle, base times height, which is 16 times 7. So we'll say that's step 1. 16 times 7 is 112. The thing we need to find out is what the area is of this triangle here. The problem is, I don't see the length of this triangle because there's a 13 here. But if you look over here at 7, you can see that 7 and 7 are of equal lengths. And if this whole thing here is 13 and this whole thing here is 7, for part 2, we're going to have to do 13 minus 7, which is 6. So then the height of our triangle here is 6. At our rectangle here, we can see that this splits up our rectangle nearly in half. So we have 16 minus 8, which is 8. And the two different factors of our triangle are 6 and 8. To find the area of a triangle, you have to use half base times height. In this case, we have half. Our height is 6. And our base is 8. Now we'll begin to simplify. 6 times 8 is 24. No, 6 times 8 is 48. And 48 multiplying by half is the same thing as dividing by 2, is 24. Now we've determined the area of our triangle, and we've determined the area of our rectangle. We can add up our two areas. So we have 112 plus 24 is 136. Since we have centimeters here, and we're dealing with area, we want to make sure we square our area. So here we're given a composite figure, and a composite figure is a figure that can be divided into another figure. So we'll start off with this question by simply finding the area of this rectangle here. Okay, and I know it's a rectangle because this is 14 here and this is 18. To find the area of a rectangle, we'll do base times height. So I'll start off by multiplying 4 times 18. That's my first step. 4 times 18 is 252. So now we have to follow our definition of a composite figure and make this into another shape. So for this particular shape, I'm going to extend my rectangle. It's important to understand with this particular rectangle that the 10 is on this line right here. Next thing I want to do is if I look at my area, I see that it's 252. I know it's not possible for it to be 252 because it's missing a chunk over here. So I know at some point I'm going to have to do some subtracting to get rid of that space. So I've extended my rectangle here. So my question to you is, what would the value be of this entire side right here? Well, if I look at the bottom here, I know it has to be 18. So step 2 is 18 minus 4, which is 14. Since I've determined the amount of length of the top part in this missing space here, so that's what I found here, I've got to do the same thing for this side over here. I know this side length is equal to this side length here, so I'm going to say this is 4. And I also know that this is parallel to this, so this whole thing has to equal 14. Determine the length of this space right here. I have to do 14 minus 4, which is equal to 10. Since I've figured out the length of both of my sides, my missing sides here, and I'm looking for area, I'll do 14 times 10 to get 140. Now step 3. Since the 140 represents a void area, or an empty area, I know I'm going to have to subtract 252 minus 140. The area does not exist. 252 minus 140 is 112. It's important to include the feet squared. Recapping, we found the area, 14 times 18, of the entire rectangle, which is 252. But then we realized that we multiplied it and we found an area that did not exist in our composite figure. So what we need to do was find the total lengths of this side and this side. This total length up here was 18, and 18 minus 4 was 14. This total length over here was 14, and 14 minus 4 is 10. Then we multiplied the two side lengths to get 140. Finally, since 140 was a devoid area, we had to subtract 252 minus 140 to get 112 feet squared. Number 3. Remember we're dealing with a composite figure here. It's a figure that can be divided into another figure. So much like the previous two examples, we'll begin by multiplying 10 times 20. And we'll get 200. We found the base, we found the area of a rectangle. The issue is, there's a little bit of a chunk taken off of this rectangle here. So we'll need to extend our rectangle. Do you recognize what shape is formed on this composite figure here? Looking at our list here, do you see? It's a triangle. So we need to find the area of this missing triangle. So we have half base times height. So taking a look at my other side here, I can see that this is 10. Do you know how long this extra piece was going to have to be? Well, the whole side is 10, and this side is 8, so it has to be 2. The same thing applies to the bottom. 20 for the bottom, and just 16 on the top. The whole thing has to be 20, and 20 minus 16 is 4. Now that we have our height and our base for our triangle, we could do 4 times 2, which is 8, and 8 divided by 2 is 4. So the area of our triangle is 4. Now we have the area of a rectangle and the area of a triangle. This is an extra chunk that was added onto our rectangle. So we're going to have to subtract it from our total, making our total area 196 meters squared. Here we're looking at a composite figure. A composite figure is a figure that can be divided into another figure. What's the definition of a composite figure? Okay, so there's a few different ways we could do this question. So here we're given an arrow or a composite figure. Remember, a composite figure is one figure that can be divided into another figure. So what I'll do is I'll divide this arrow right down this line here. Both ends of this triangle are worth 5. So I'll start by adding 5 plus 5. Now I notice that this part here is worth 10. So the entire side length of this triangle is equal to 20. 24 minus 18 is 6. So now we found the two different, so now we found the height and the length or the base of our triangle. The area of a triangle is equal to half base times height. We have half times 20 times 6. 20 times 6, well, let's start off by doing a half times 20, which is 10, and 10 times 6 is 60. So now we found the area of our triangle. So step 2. We have to find the area of a rectangle we created. So it cuts off here. So we'll do 10 times 18, it's base times height, to equal 180. Step 3. Since we're finding the area of this triangle and this rectangle, we're going to have to add the two areas together. 180 plus 60 is 240. And we're dealing with area, so we need to do feet squared. So here we're given a composite figure. So to start off on this one, what I want to do is I want to add little chunks to our chunks here. So what I'll do is I'll add everything on my left side, 1 plus 3 plus 1, which is 5, and I'll add everything on my top, 1 plus 4 plus 1, which is 6. Since we have a rectangle here, we'll multiply base times height, which is equal to 30. Since we calculated the area with the missing pieces, we're going to have to subtract at some point. So how many missing pieces, what's the area of each missing piece? 1 times 1, which is 1. So 1 plus 1 plus 1 plus 1, which is equal to 4. Finally, our third step. Our total area is 30, minus the chunks is 4. So we end up with 26 feet squared. CJ is making banners shaped like triangles out of a rectangular piece of fabric. He cuts out 2 triangular banners shown. What is the area of the triangular banner? So it looks like we're going to have to find the area of this triangle. To find the area of a triangle, you have half base times height. So we'll have to do 7 times 21 times a half. 7 times 21 times a half is equal to 73.5. So the answer to our first question is 73.5 inches squared. What are the dimensions of the fabric left over after CJ cut out the 2 banners? What are the dimensions of the fabric left over after CJ cut out the 2 banners? Cut out means take away or subtract. So we've gotten rid of these 2 banners right here. If this whole entire side here is for 28, and we've gotten rid of 7, that'll leave us with 28 minus 7, which is 21. Now when you write the dimensions of a problem, it's like writing it as a multiplication problem. So if we took away 7, that'll leave us with 21 on the other side times 21. So the answer is 21 times 21. Today we learned how to find the area of composite figures. Thanks for tuning in.
Here is a circle, it knows how to get around. It has a radius from center to rim, and its diameter's a line that goes from side to side while passing through the center. Now isn't that simple? Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Here is a circle, it knows how to get around. It has a radius from center to rim, and its diameter's a line that goes from side to side while passing through the center. Now isn't that simple? Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d.